In this nugget, we get to walk through the solution for troubleshooting ticket number 7. Now, before we dig into the solution for this trouble ticket, let me point out something that I think is actually quite interesting and important to know, and that is this. If we have a 2-hour exam for CCNP Troubleshoot, you may get somewhere between 21 and 24 questions in your T-Shoot exam. And then out of those questions, you might get, for example, 14 to 17 interactive scenarios, like the ones we're doing here, where you have to identify the fault domain, the technology that has the problem, and the correct command or commands to solve the problem. And for round numbers, let's say we have 120 minutes. If we divide that by 15 questions that are scenario-based, that gives us about 8 minutes apiece to solve the trouble tickets. And actually, that doesn't even account for the additional multiple choice questions. So you might have 5 to 10 additional multiple choice questions besides the scenarios that you'd also have to answer. So the point I want to bring up right now is that as you're going through these trouble tickets and working through them, your speed should be improving for a couple of reasons. Number one, you're more familiar with the topology. You know basically where a subnet is without having to look at the topology every single time. And also, because you've looked at a lot of the devices already, you've got an idea of their configs. So the ability to troubleshoot the scenario and do it in a fairly quick period of time are both critical factors for the T-Shoot certification exam. So with that said, let's get right to the problem of why PC1 can't ping the internet server. So our first step is right here on DSW1. We're going to go into interface VLAN 10, bring it down, and then we'll bring it back up. I know that the first time I don't do that, it'll go ahead and bite me during the demo, and I just want to get it out of the way. At least that's what Murphy's Law would say, is that it would bite me when I least expect it. So next, let's go to PC number 1, and on PC number 1, let's use the command IP space DHCP, and we've got discover, discover, discover without any offers. And so the virtual PC simulator is telling us can't find a DHCP server. Now we know from the topology that PC1 is connected, or should be connected, to port 1/11 on ASW1. So let's go up to ASW1, which is the access layer switch that's supporting PC1, and let's use the command show interface status. And that'll do a few things for us. Number one, it can verify that that port is connected. So there's FA 1/11. It shows us connected. That's great. And it also shows us that it's assigned to VLAN 10, which is great. So to mix it up a little bit, let's do this. Let's go back to PC1. And on PC1, let's statically assign an IP address of 10.2.1.10 with a 24-bit mask using .254 as a default gateway, just to verify whether or not our local TCP/IP protocol stack is working. And because PC2 should be in that same VLAN based on our show command we did earlier, let's also give it an IP address but use .20 in that same subnet. And from here, PC2 should be able to ping 10.2.1.10, which is PC1's address, and sure enough, no problem. So we know we have good, clean communication from both of these devices to the access ports they're connected to on ASW1. And these two PCs, based on the output here on ASW1, they are both in VLAN 10. Now what we could also do, let's go back to PC1 for a moment. On PC1, let's go ahead and ping our distribution layer switch. Let's ping its real IP address, which is 10.2.1.1, and see if that responds. And it doesn't. So let's ping the VLAN 10 interface on DSW2, which is at 10.2.1.2. And that is also not coming back. And if we do a show ARP, and that shows us that the layer 2 addresses for 10.2.1.1 and 10.2.1.2, they were not resolved. So it didn't even get past ARP for those two devices. And this is the ARP entry for PC2's address at 10.2.1.20. So let's look at our topology and think about this together for a moment. PC1 and PC2 can talk to each other. They're both in VLAN 10. That's not a problem. But PC1 cannot ping the 10.2.1.1 address, which is the VLAN 10 interface address of DSW1, nor can it ping the 10.2.1.2 address, which is the VLAN 10 interface of DSW2. So some possible reasons for that could be that perhaps these interfaces are down. I know we just bounced the VLAN 10 interface on DSW1, so it's definitely not down. And because it's not down, the next thing we might look at are these links between ASW1 and distribution switch 1 and distribution switch 2. If these are not configured as trunks, or if they're down, or if they're not allowing VLAN 10 traffic to go across them, which would also be a reason why we were not able to get a DHCP address here on PC1. So let's do this. Let's also verify on DSW1. Let's verify it has the right IP address on the VLAN 10 interface. Let's do a show IP interface brief pipe exclude any lines that have the word unassigned in them. That way we don't have to sort through a whole bunch of interfaces that are switch ports. So here's VLAN 10, and sure enough, it's got 10.2.1.1. So if the IP address was wrong, that would be another reason why we would not be able to ping the 10.2.1.1 address if it wasn't in use. But it is. Let's also do a show standby for interface VLAN 10. And this says that the state is active. That's great. But I do see a problem down here. Look at this. It says the standby router is unknown. So for whatever reason, the VLAN 10 interface on DSW1 is not communicating with the VLAN 10 interface on DSW2, or at least not from an HSRP perspective. So let's go take a look at DSW2, see what it says. So here on DSW2, let's do a show standby for VLAN 10 and see whether or not he's even running. Yeah, so DSW2 is running HSRP, and oh, bummer. Unfortunately, DSW2 believes he is active for the HSRP group 10, which is associated with interface VLAN 10. And he also says that the standby router is unknown, so that is a huge problem. DSW1 and DSW2 both believe that they are the active router for HSRP group 10. And they both can't see each other. Now, one possible reason for that would be if the trunks are all down. If the trunks are all down and not forwarding traffic, that would be a great reason why those two distribution layer switches cannot see each other on VLAN 10. And we can verify that really quickly with a show interface trunk right here on DSW2. And based on the output, we are forwarding VLAN 10 and VLAN 20 traffic on both of our trunks. So as a refresher of where those trunks go to, here in our topology, trunk 1.1 goes to access switch number 2, and trunk 1.3 goes to access switch number 1. And both of these are carrying VLAN 10 and VLAN 20. And because this link between DSW1 and DSW2 is layer 3, the path that DSW1 and DSW2 could see each other on would be this path right here for VLAN 10, and possibly this path right here. That's if switch ASW2 has VLAN 10 defined, which I don't believe it does. So because VLAN 10 doesn't exist on ASW2, that wouldn't be a possible path for DSW1 and DSW2 to see each other's VLAN 10 interfaces. So that leads me to believe there's still some type of an issue on the trunks here between ASW1 and DSW2 that's preventing traffic from flowing. So I propose we make a road trip over here to ASW1 and take a look at the trunks from ASW1's perspective. So here on ASW1, let's go ahead and do a show interface trunk just to make sure that VLAN 10 is active and forwarding on all of the trunks. And there's your problem right there. Look at this. VLAN's allowed on trunk. Basically everything except for VLAN 10. And as a result, because ASW1 is not allowing VLAN 10 on either of its trunks, it has basically isolated DSW1's VLAN 10 interface from DSW2's VLAN 10 interface. And more importantly, our PCs. PC1 and PC2, they can talk to each other all day long because they're both connected to access switch number 1, but they're never going to get their traffic off of that local ASW1 switch because that switch has no trunks that are currently carrying VLAN 10 traffic. And by the way, allowing a single switch at the access layer to control your success of your distribution layer switches is criminal. And a simple fix for that could be a layer 2 connection between DSW1 and DSW2. We'll take a peek at the running configs for our trunks with the command show run interface FA1/1, and sure enough, they have allowed everything except for VLAN 10. And let's also do a show command to see the running config for interface FA1/3 as well, and yeah, it's the same exact treatment. VLAN 10 is administratively prohibited from traveling across either of those trunks. So it's our job to fix it. Let's go into configuration mode, and we'll go into interface range config for FA1/1 and FA1/3, and we'll just add the VLAN back on to the trunk with the command switchport trunk allowed VLAN add 10, and poof, it will add 10 back into the mix. And then if we issue the show interface trunk command, and with the do thrown in there because we're in configuration mode, you'll notice, although it's now permitted, it's allowed on the trunk, VLAN 10 is, you'll notice that the very bottom part, VLAN's in spanning tree forwarding state and not pruned, we still don't have VLAN 10. And that is because I'm running the traditional, old-fashioned flavored 802.1d, which is going to take about 30 seconds for it to converge. So after waiting a few moments and hitting the up arrow key, we can now see that VLAN 10 is allowed because spanning tree has converged and is now allowing VLAN 10 traffic on those trunks. So we'll exit out of configuration mode. And just to confirm, let's go up to DSW1 for a moment, who should now, oh, there we go, see? They have a brand new adjacency between DSW1 and DSW2 because they can now see each other on their VLAN 10 interfaces. And if we use the up arrow key and do the show standby VLAN 10, it still shows that the state is active for DSW1, and it also shows that the standby router is the interface 10 IP address of DSW2. So that's as it should be. Now, if we make our way back to PC1, we still have a static IP address here on PC1. And with that static IP address, with a correct default gateway configured, we should be able to reach the internet server. Let's test that by doing a ping to 209.65.200.241. And survey says, oh, timeout. Okay, well, we're very, very close. Can we ping our default gateway, the .254? Let's try that. We'll do a ping 10.2.1.254, and it is not responding here. So if we just take a peek at our trunks for a moment, go back to ASW1, it shows us that we're currently allowing VLAN 10 on the trunks. DSW1 and DSW2 saw each other. They became EIGRP neighbors over VLAN 10, so we know that VLAN 10 is functioning. And here's what I think it might be. I think this may be a situation where DSW1 is rearing its ugly head with the HSRP issue. Let's do this. Let's go to PC1. Let's do that ping again. And let's issue the command show ARP. Look at that. I am surprised. It actually did the resolution for the layer 2 address of the default gateway, which implies that DSW1, who is the active router for that HSRP group, did indeed respond with that layer 2 address. However, we still can't ping it. So what I recommend we do now, because the trunks are in place, but we simply can't ping our default gateway, let's go ahead back to DSW1 and let's give him a bounce. Let's go to interface VLAN 10. We'll shut it down just as we did at the beginning of the lab, but we did have some issues with trunking and VLAN 10 in the mix here, so perhaps that's part of the problem. And let's bring it up with a no shutdown command. So earlier in the lab, we did the same process on VLAN 10 interface, but during that time we also had isolation with VLAN 10 due to the no trunking of VLAN 10. So with that back up, let's go back to PC number 1, and let's do a couple of things. Let's do an IP DHCP. Just as a comfort level that the trunk is working, if we do get an IP address from R4, the DHCP server, which we are, that's a great sign that the trunk is working between access switch number 1 and DSW1. Let's hit the up arrow key a few times and do a ping to our default gateway address. So I'm going to attribute this little issue right here that we just experienced to the HSRP issue with VLAN 10 interface on DSW1 that we've been doing preemptive strikes against at the beginning of each of our troubleshooting tickets. And now that we can ping our default gateway, let's use the up arrow key a few times and just verify that we can ping the internet server at .241. And survey says that is now working. In this walkthrough for troubleshooting ticket number 7, we identified that one of our fault domains was on ASW1. The technology was VLANs that were not allowed on a trunk or trunks on that switch, and the fix was to allow VLAN 10 on those trunks. We also had an additional issue of the DSW1's VLAN 10 interface not responding to a ping request, which required us to bounce that interface to get that connectivity restored. And with that default gateway now functioning, we are then able to test from PC1 full connectivity out to the internet server. I appreciate you joining me for this nugget. I hope this has been informative for you, and I'd like to thank you for viewing.